Hey, welcome back, and in these videos I'm going to talk about the integers and floating point numbers in c-ruby API. Make sure you have followed along with the first video of this series because I'm not going to repeat myself. In the first video we have talked about how to compile our code and how to create strings and global variables. We do have this code for reference now, but I'm going to remove this one from here. I'm going to assign a number to it. So let's assign 501 here. If I compile and run it, as you can see, we get 250. What's going on in here? I wrote 501 and it is getting 250 for me. 501 isn't 250. So to explain that, let me open the IRB console. So if I do 501, sorry, we are getting 250, right? So if I do 250 dot object ID, you can see it is 501. If I do 1 dot object ID, I get 3. If I do 2 dot object ID, I get 5. If I do 3 dot object ID, I get 7. If I do 4 dot object ID, I get 9. If I do 6 dot object ID, I get 13, right? If I do 10 dot object ID, I get 21. As you can see, if we increment the number by 1, we increment the object ID by 2 in Ruby. For example, if I put 21 here and compile and run it, you can see we are getting 10. But if I do 23, I should get 11, right? Yeah, we get that. If I do 25, I get 12. But this is a very crude way to program in ruby-c extension. We don't do that, and this is quite buggy. For example, if you write something like 26, you get a totally different number, 2 point something, a floating point number, right? If I get 27, I get 13 as I should, but if I do 28, which is even and not a valid object ID for integer in Ruby. So as you can see, if I do 28, it again crashes our whole Ruby, which is really dangerous. And I told you to avoid these kind of things because this is a really big bug, right? So it could crash your Rails server or anything you are running. It will just crash your whole Ruby environment. So we don't want that. We want a reliable way. And so we have a function called into_fix. We can run into_fix 200 and get maybe 200 exactly. So if I do 201, it will convert the C number 201 to Ruby number 201, right? So we get the number here. If I run say class, it is an integer, right? So we get 201 exactly here. But what if I have a very big number like this? It works for now. To be on the safe side, to avoid crashes, we also have into num, which converts bigger numbers to big nums, right? For example, if I have a 32-bit number, maybe like this, 2 to the power of 31, we can maximum have a number like number of this length in Ruby. As you can see, into num converts it to a negative number because it is integer to number, right? And this is the maximum range integer can support. But if I do to 48, it is a negative number. If I do 49, it overflows, right? So we are having integer overflows. I don't want that, right? So we can do something like uint to num. So we can call it unsigned integer, and unsigned integer is converted in a Ruby number. So we do have exactly 48, and we can increment it to maybe 49 as well. It will work. We can also make it to 3 billion, and this will also work because the value of unsigned numbers are actually twice as the integers in most cases because there's no signed bit, right? For example, the maximum number that unsigned will support is this number. So we can just copy it and paste it here. And this should compile, right? And this should compile and return the number, right? Also, we have other methods, right? So let me declare them. For example, int a equals to 5. In this case, I will use into_fix to save some memory. I can call it into_fix a. And if I compile and run it, I get 5. But if I have an unsigned int, I have to do u into fix, but there's no u into fix. There's u into num. So you can write u into num and it converts. And if I keep it u into fix, you will see there's an error here, right? Because there's also into fix, but there's also u into num. Sorry, into num. Now, if I want to convert it to a long number, we can do long to num. We can call it long a equals to 5. Long to, sorry, I have to spell it right. Long to num. You can see it converts it to a long number. But what if I have an unsigned long number? I can run unsigned long. So I can call it u long to num. It will convert the unsigned long to a Ruby number, right? And we also have ull to num, which is for unsigned long. We also have ll to num for converting long numbers to Ruby number. Now that's all about the integers. To create a floating point number, you have to write rb new float, maybe 2.125, I don't know, and we don't need this one. Okay, so we need to call it value abcd here. Sorry, I made a mistake. It is actually rb float new, not rb new float. And you can see that I have converted that to 2.123 Ruby floating point number. So if we run class on it, it is actually a float. What if we have a double, right? So if we have something like this, double a equals to 1 2 3 4 5 6 7 8 9 0 0.123 4 5 6 7 8 9 and 0. So we have this double number, and if we want to convert it to float, we can run this, but this is quite buggy actually, because we are missing the semicolon. This is buggy actually. This works. Ruby also has double to num, and if you run this, you can see it also truncates. But this is the appropriate way to convert a double to a Ruby floating point number. If you want to have some big numbers and stuff, you have to do string with the mpfr or maybe the gmp library in C. So that's it for the integer and floating point number part. See you in the next one, where we are going to discuss about functions and how to create module functions and stuff. I do thank you for watching and hope that you have a great day.